Welcome back, math friends. Today we are taking a look at lesson 6.1. So please make sure on the next page in your math notebook you indicate that this is lesson 6.1, chapter 6, lesson 1, and we're going to be solving one-step linear inequalities. Oh, inequalities. Taking a step away from equations for a while to work on inequalities. Now, the graph of a linear equality in one variable, meaning you have just one variable that you have to solve for, is the set of points on a number line that represent all of the solutions of the inequality. So what does that even mean? Well, let's take a look. Here are some verbal phrases, the inequality that goes along with them, and the graph that matches. Our very first one here, it says all real numbers that are less than 2. Now notice the inequality says x less than 2. Now that's less than because as you read it from left to right, we have less points here than we do here. That's what makes that less than. X is less than 2. And then the graph of this, if we look at our number line here, we found the number 2 on the number line, put a circle there, and then it's all the numbers that are less than 2. So that's why everything is filled in all the way that way, because those are all the real numbers that are less than 2. Notice how the 2 is not filled in by the circle because it does not include 2. It's everything less than 2. Okay, let's take a look at the next one. This one says all real numbers that are greater than negative 2. So we see here x is greater than negative 2, greater than because it has more points here than here, greater than, reading left to right, greater than negative 2. So we find negative 2 on the number line. Oh, look, there it is. We put a circle there, and it's everything that is greater than negative 2. Notice again that the circle is not filled in because it does not include negative 2. Negative 2 is not greater than negative 2, so it's an open circle because it does not include the number negative 2. Now, the next one says we're looking for all real numbers that are less than or equal to 1. Less than or equal to 1. Here's what it looks like when you write it algebraically. X, all numbers less than or equal to 1. Notice it's got the less than symbol and then an extra line which would indicate or equal to. Okay, so any number that is less than or equal to 1. So we find 1 on the number line, draw a circle around it, and of course it's everything that is less than 1. Now because it's less than or equal to, that means it also includes 1. So we fill that circle in. That's why the circle is solid. Instead of an open circle, it's a closed solid circle because it includes 1. And our last one, all real numbers that are greater than or equal to 0. All right, here's how it's written. X is greater than, you see the 2 points here, 1 point there, or equal to, we got the extra line under there, greater than or equal to 0. So we find 0 on the number line, there it is, and it's everything greater than 0, but because it's greater than or equal to, it also includes 0, so we fill that circle in. So again, remember, the open dot is used for less than or greater than, the solid dot is used for less than or equal to or greater than or equal to. So keep those things in mind. Write that in your notes. Write all this down in your notes. If you haven't copied all this down, stop the video and do it now. This is really important stuff. All right. Now let's see this stuff in action. Sue ran a 2-kilometer race in 8 minutes. We can write an inequality to describe the speeds of the runners who were faster than Sue. And then we can graph the inequality. So, keep in mind, in a situation such as this, speed is equal to distance over time, distance divided by time. And so a faster runner's average speed would have to be greater than Sue's speed. So, the faster average speed would be greater than the distance divided by Sue's time. Now, so we're going to label these things. The faster average speed would be S measured in kilometers per minute. The distance is 2 kilometers, and Sue's time was in 8 minutes. 8 minutes, see? 2 kilometers in 8 minutes. So that we can write the algebraic model of this, the faster average speed would be greater than 2 divided by 8, 2 over 8. 2 kilometers in 8 minutes. Now we can simplify this because each of these, if we divide 2, hold on a second here, there we go, 2 divided by 2 and 8 divided by 2 simplifies to 1/4. So S is greater than 1 over 4, 1/4. And then now we graph it, we find 1/4 on the number line. Notice we had to break this number line into smaller sections. And we found 1/4. It is 1/4 of the distance between 0 and 1. We find that distance. It's got to be greater than, it'll be all numbers greater than 1/4. So we, like that. And is 1/4 included in this? Is it greater than or equal to? No, it's just greater than. So we leave that circle open. See, that's how you can take these word problems, create an equation or an inequality, and solve it and graph it. So let's solve a one-step linear inequality. It's really similar to solving a linear equation. In fact, it's almost exactly the same. So you have to isolate the variable, right? Get that variable by itself on one side of the equation using inverse operations, opposite operations that will produce equivalent inequalities. So notice on this one, the original inequality is x minus 3 is less than 5. We would have to add 3 to both sides of the inequality. And when we do that, those cancel out, and x would be less than 5 plus 3, which is 8. So that's the equivalent inequality. And so for this one, x would be all numbers less than 8. So we found 8 on our number line, which would be like right there. And everything less than 8, everything would be this way. And it doesn't include 8, so we leave that circle open. That's how we'd graph that. The next one is x plus 6 is greater than or equal to 10. So if we subtract 6 from both sides to isolate the variable x, then we end up with x on one side. So x is greater than or equal to 10 minus 6 is 4. And so that's our solution. To graph this one, we'd find 4 on the number line. There it is. We colored in solid because it's or equal to, and it's greater than that. So everything that direction. Okay, so now let's try one of these. We're going to solve x plus 5 is greater than or equal to 3. All right, so I'm going to write this down. X plus 5 greater than or equal to 3. I want to get x by itself. So 5 is being added to that. I'm going to use the inverse operation and subtract 5. Those two cancel out on that side, and I get x is greater than or equal to 3 minus 5. 3 minus 5 is the same thing as 3 plus negative 5, and that would be negative 2. So now we go to graph this. I find negative 2 on here, circle it. It's greater than, so everything this direction is greater than, or equal to. So I got to color that circle in. See, there you go. All in, all done. X is greater than or equal to negative 2. All the numbers that are greater than or equal to negative 2. Let's try this next one. Negative 2 is greater than n minus 4. So we're going to, got to get n by itself. So first things first, negative 2 greater than or equal to n minus 4. Got to get n by itself, so I'm going to add 4 because that would be the opposite of subtracting 4. Add 4 to both sides. These two cancel each other out, and I have n over here. N is less than the n like that, okay? And negative 2 plus 4 is positive 2. So positive 2 is greater than n. I don't like the way that one's written, so I'm going to turn it around. N less than 2. So notice, when I go to turn these things around like that, I have to change the direction of the inequality symbol, because if it's like opening to the 2 when it's like this, it has to open to the 2 when I turn it around. Now when I go to graph this, I got to find 2. There's 2, put a circle on it, and everything less than 2, so it would be everything to the left is less than. Is it less than or equal to? No, it's just less than, so we leave that circle open. We do not fill it in. All right, but now what about when we do multiplication or division? Well, let's take a look-see. Now this is x divided by 3 is less than or equal to 2. Well, x is being divided by 3, so we have to do the opposite of that. So I'm going to multiply by 3, because that's the opposite of division. Those two cancel each other out, and I get x is less than or equal to 2 times 3 is 6. Go to graph that thing, find 6 on the number line. There's 6. Everything that is less than 6. X is all numbers less than 6, so everything this direction. But it's less than or equal to 6. So that means I have to fill that circle in because it includes 6. All right, now let's try this next one here. -4 times m is greater than 6.3. -4.2 m greater than 6.3. All right, well remember, when we have a number next to a variable, that means multiplying. So the opposite of that is to divide. So I'm going to divide by -4.2. -4.2. And when I do that, those two cancel out. Now this is where something gets really important. If you divide by a negative number, you must turn your inequality symbol around. Because if you don't, all kinds of horrible things happen and you get the answer wrong. So you have to remember to turn the inequality symbol around when you multiply or divide by a negative. So 6.3 divided by -4.2, well, it's going to be -1.5. So we find 1.5 on here, -1.5, so it's about here. And then everything less than that, be like that. And remember, we are leaving that open because it is not less than or equal to, it's just less than. So, important stuff to remember. When you multiply each side by the same positive number, you get something like this. When you divide each side by the same positive number, notice the inequality symbol does not change. When you multiply each side by the same negative number, you have to reverse the inequality symbol. Notice it's less than here, and now it's greater than there. You must reverse the symbol. When you divide each side by the same negative number, we have to divide this side by -2, -2. The symbol has to change and point the other direction. That's how it is when you multiply or divide by a negative with inequalities. Really important to remember. All right, here's your practice for this assignment. You can find these on the slide where you found this video also, but in the meantime, you can always just copy it off here too in your math notebook. Have a great day, math friends. Don't forget to be awesome. I'll see you next time.